last time, you spent your time introducing to the topic of algebra, right? And I think the last thing you looked at was variables. Variables? Variables. That's a weird word. What are variables? Yeah,
When letters represent numbers.
Okay, so the first thing we said was, okay, when we introduced it before, right? Letters representing numbers, okay, and we gave them a special name. Do you remember when a letter represents number, Ash? Pronumerals, exactly. So when you see a letter, but it's not really a letter, it's a number in disguise, we call that a pronumeral. That's good, but we still don't know, like, why are they called variables? That's a weird name. What?
Variables can be any number.
Okay, so they could be anything, right? I think we're getting closer, but we're still not at the idea. What does variable, like as a word, what does variable mean, Kyle?
Vary means like different.
Yeah, that's right. So the idea of a variable is it can vary, it can change. These numbers, they can shift around, they can take different values, depending on what kinds of situations and expressions you find them in. Okay? Kyle.
And the example is there's
A plus B. A plus B equals 12, was it? Okay, good. And so you can see the idea here, right? You've got two letters that represent numbers, two pronumerals, right? And the point is that you can put in lots of things into A and B. A and B can change, right? If I made A 3, you would make B 9, hooray! Too early in the morning. If I made A 11, you would make B. What? I heard a 12. I would make B 1, 11 plus 1. You get the idea. Okay. So we've got these variables, right? Numbers that can change. Then we introduced a whole bunch of laws, capital L laws, that govern the way these pronumerals, these values interact with each other. Now there are three kinds of sets. Do you remember what any of them were? I'll give you a clue. They start with C, A, and D. Who wants to give me the first one? Morgan. It's there somewhere.
Distributive law.
Okay, hold on. Distributive was the first one you said. We'll come to him. What's the first one, Kieran?
Commutative.
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 I don't blame you. I mean, it is commute. That's how you say the word commute, and then it's like H. So anyway, but I think we do say the commutative laws, plural. Now there are two. What are they? Do you remember what they are? Ash.
I think they're like if you times it and like plus it, it's the same backwards.
Okay, all right. So let's write these out. We had some equations that represent these laws, right? Morgan, give me the first one.
9 plus 3.
Pause.
What are you doing?
What's he giving us? He's giving us an example of the commutative law, but I want to know what's the law itself.
If
Okay?
A and B are numbers, then A plus B equals B plus A. And A times B equals B times A.
Okay.
How are you abusing yourself?
Thank you for that. It had to be said with that tone of voice, didn't it? Now, let's look at this. So hopefully you have this in your book. These two here, these are the commutative laws, okay? They work for addition and multiplication, but not for subtraction and division. Okay. Didn't I just say it? Anyway. Now, here's the important thing. I mean, commutative, that's a weird word. We actually talked about this earlier in the year, but in my head, the way that I think about these is, A plus B, people say, what's changing? What's changing from one side to the other?
The pronumerals.
The order is changing, right? Namely, here, it's reversed. So I call the commutative laws, I call them, and textbooks will never call them this, but I just want you to know what's going on. I call them the reversible laws. Because it refers to the fact that addition and multiplication can be reversed and they still stay the same, okay? You can add numbers and you can add them backwards and you'll still get the same sum. And it's the same with products, okay? Good. Now, the associative law is this one in the middle, associative. And I hope you got that written down as well. I always found the associative laws a bit weird. Again, there are two of them. Someone who hasn't said anything yet, can they tell us? Yeah, Ali at the back.
If brackets A plus B plus C equals A plus B plus C in brackets, something like that.
Something like this? Am I hearing it right? Okay, alright. So hold on. Go back to, you don't need to necessarily write it again, but look at where you've got it written. It's a bit weird. What's changed? Here, the order changed. I reversed, right? What's changed here? Yeah.
Numbers in the bracket.
Good. So all I've done is I've moved these brackets here from the first two. I've moved them over here to the last two. And of course, the other associative law is exactly the same, but with multiplication in all the same spots. Okay? Now this is important. You need to get that these two are different, but they feed off each other. Okay? The associative law comes from the commutative law. The commutative laws tell you can reverse things. Okay? You can reverse things. You can do them, this first or that first, doesn't matter. Okay? Now, the associative law kind of takes it to the next step. When you put brackets in, right? In terms of like your order of operations, are brackets like in the middle, or are they last, or are they first? Where are they? When do you do brackets? Yeah, Rashad.
I think they could be anywhere, and then you just do them first.
Ah, good. So like they can be anywhere in the expression, but when you see them, you're like, it doesn't matter that this A is first. You've got to go to the brackets first, right? Does that make sense?
Yeah.
Right. In fact, brackets. That's what the B in Bottomless stands for. It's right at the front, right? Do brackets first. So what this is really saying is, if you've got three numbers, you might add them together. Okay. You can add the first two first, and then do the last one. Or, you can add the last two first, and then do the... Doesn't matter. Doesn't matter, right? So these laws are the reversible laws. But, red. The associative laws, I like to think of them as the any order laws. If you're adding numbers, or if you're multiplying them, right, you can add and multiply in any order you like. You could have 100 numbers that you're adding. It doesn't matter if you start on this end, or that end, or in the middle, or wherever you like. Okay? You can place the brackets which tell you where you should start, and you can place them anywhere. Okay. Right. Yes? No.
Can you place the brackets anywhere because it doesn't really matter?
Well, I'm gonna go on to the next bit, and then hopefully that'll tell you whether it matters or not. Okay? The distributive law. In some ways, this is the most important of the laws. Okay? What does the distributive law mean? I think it's the best name. Yes,
Is it like expanded form of multiplication?
Can someone give me a what is the law? The actual starts with an A, and then what happens after that? Yeah, Lucy. Yeah. Or Jasmine, doesn't matter. It's whoever.
It's like when we have 15 times 9 and then it equals 15 times 10 minus 1.
Okay, so you're giving me a good example. I'll write that down in a second. Can someone give me what's the law itself, and then I'll write yours down. Yeah, what?
A times bracket B plus C equals A times B plus A times C.
Okay, all right. Now, let's look at this guy. Let's look at this guy. This is important. Also, you might have learned before. Tell me if you haven't. That there's some shortcuts to writing this, particularly with multiplication, right? Instead of writing the multiply sign all the time, sometimes we just omit it, right? So, for instance, we might write this, and I still read that as A times B plus C, or A multiplied by B plus C. So it's sort of hiding in there, and we just say, shh, just pretend he's not there, but he's still doing his thing, right? In the same way, how would you write the right-hand side? Whoops, this is wrong. That should be an A. Sorry. How would I write that without the multiplication signs? Yeah, Ash?
AB plus C.
Yeah, good. Now, I kind of like this. Have you guys seen that before, or is that new? Yeah? No? Raise your hand if you've seen it, because somebody... Okay, excellent. That's more like it. Great. Now, I like this because without all the time signs there, it's a little easier to see what's going on. What is the distributive law? What's being distributed? Because we know what distributing is. What's going on here? If I say I've got papers and I'm going to distribute them to everyone, okay? That means I'm giving you all a paper. That's what distributing means, right? So what's being distributed here in this line? What's going on? Someone hasn't said anything yet. Yeah?
Numbers that you're like
Okay, now, I've got 3 numbers here, right? Which is the number that I'm multiplying by? It's... Now, this is a number. This is a number as well. The one that I see being added onto, multiplied by the others, is the A. Can you see this? There's the A there. The A got distributed to the B. Here you go. Have an A. Enjoy yourself, okay? And then, the A gets distributed to here as well. It gets given to the C at the same time. Now, the way I like to picture this is a bit like, let's say Mr. A here, okay? There you go, there's Mr. A, right? Mr. A comes to visit a new house, right? And it's got inside, okay, 2 people, B and C, right? Now, you guys know, if you don't know already, right? If you ever come to someone's house, right? You should say hello to everyone inside. It's not that nice to like kind of just say hello to your friend and then sort of ignore everyone else in there. So Mr. A is polite. He says, hello B, and then he says, hello C, and that's what this is, right? There's one greeting there, and then another greeting there. And we call him a bit of a jerk. If you were like C, and he just said hey to B and then ignored you, you'd be like, I don't like A anymore. Okay, but, that's right, but, you know, this is the way we want to do it to make sure we do it all the way across. And, find something else here. Let's expand it a little bit. You didn't see this before, but I think you could work out what it would do. If there were not 2 people in the house, but 3, what would you expect that to be equal to? Yeah, Jasmine. Good. So, poor old Mr. A, right? He has a lot of people to greet. But that's the way it works, because all these people, they're all in the house, right? They don't have to greet each other because they're in the house, they're one family. But A greets everyone, right? Okay, so you can see what's going on. Good, that was revision. You can rule that off. Yeah, question?
That's some delightful ways to teach us.
Oh, thanks, Martin.